we need to talk about sexes and how to address the prevalence of single-sex animal studies, because this has been identified as an issue. So there's a sex bias, most often than not, a male bias, a tendency to just use males rather than both sexes. And in some cases, particularly if these are studies in longitudinal, long-term chronic diseases, this might turn into a female bias, but a bias nonetheless. So we have identified this problem. And the NIH actually, back in 2014, issued a statement saying, we want every preclinical research funded by the NIH to use both sexes, when there is no justification for doing otherwise. And for some reason now, in 2025, they are backtracking this because supposedly, for some reason, they think this is woke. But there are both ethical and scientific issues with just using one sex. This is from a small study that we did with focus groups with animal caretakers and technicians and vets on the impact of, in terms of compassion fatigue, of the unnecessary killing of laboratory mice, how that affects morale within the facility, how that affects the mental health and emotional well-being of caretakers, and needlessly killing was identified as the main cause of unease within the animal facilities staff. And recently, particularly in Germany, the killing of animals in and of itself without any purpose, so animals that were bred as surplus, was pointed out as probably a potential crime of sorts. This might be a bit of an exaggeration, but indeed it shows us how much of an ethical issue this might be. As Dayton and all stated, the main reason for the predominant use of male subjects is simply inertia, but inertia compounded by the following assumption that the estrous cycle of female rodents imposes additional variability on experiments. This goes back to, say, Verdi, who would say, oh, la donna è mobile, the female is volatile. That's very unscientific, and of course, Verdi was not a scientist thing to say. And actually, a well-renowned researcher once said today that inertia is not really a reason, it's just an excuse. So there are a number of misconceptions, one of them being that using just one sex is compliant with the 3 R's principle of reduction. But actually, even back in the 50s, Russell and Birch, what they stated about reduction is that one should use as few animals as possible, but to obtain information of a given precision, not just fewer animals. And actually, single-sex studies often provide less information. Another misconception is that one would double the sample size. Oh, now I have 2 sexes, I have to use twice as many animals, twice the trouble, twice the money, and twice the space. What say you? But actually using both sexes does not equate to using twice as many animals. So we can use factorial designs that actually allow us not only to test 2 factors at a time, but also to test for interactions between said factors with negligible power loss. Yet another misconception that females are too variable. But the evidence, the published evidence, shows that they are not more variable than males, or the other way around. Importantly, males and females might, for a number of parameters and pathophysiological conditions or response to drugs, males and females might be different. And if that difference exists, it is of scientific, medical, and ethical relevance for us to be able to identify it. And actually treating males as the default sex, in a way, introduces bias and reduces validity of our research. So I mentioned factorial designs. What are these? So I will resort to the grades to, in a way, explain what these are. So Kempthorne said, in most fields of research, interactions have been found to exist. Success of experiments varying one factor at a time can only be attributed to the fact that, in general, interactions are of lower magnitude than the main effects. As Mead said, a factorial design actually allows experiments to be, several experiments to be done simultaneously because we are analyzing several factors at the same time. As Michael Festing pointed out, factorial designs are, one, more efficient, and two, they are more comprehensive since both main effects and their interactions can be evaluated in a single study, and conclusions can be drawn that have a broader range of applicability because they have been replicated across other variables of interest. Importantly, it is important that the analysis of a factorial design is done by a two-way ANOVA rather than multiple t-tests. Otherwise, yes, one would lose power. And factorial designs basically allow can be applied in both blocked and unblocked designs. And what we typically do is rather than just comparing 8 males with 8 males treated with a drug, or 8 males treated with a vehicle, or 8 females with a drug and 8 females with a vehicle, basically we split the group size and we have 4 treatment and we have 4 males for females per drug treatment. Because there's nothing worse, and I've heard this. Let's test on males first, and if it works, in a way, we then can validate it on females and then test it on females. So something like this, so you compare the vehicle with the drug just in males, and then you do if it works, but now we need validation in females. As you probably have already spotted, this is inherently biased. We are only doing one of the studies based on the result from a previous study. And actually, because we are doing differently from what one would do in a factorial design, we are using twice as many animals. And we are missing, because we're doing one factor at a time, the information about the sex and drug interaction. And then we have all confounding variables that might affect your interpretation, your results. For example, if you do it in another time, you will use animals from different batches in a different season, perhaps handled by different caretakers. So to what extent can you actually attribute the differences between the results to the sex or to the conditions? So this is not scientific valid, and it's not 3Rs compliant. And it's actually worse, because if you go to the facility and say, well, for the time being, I'll only use male mice or female mice. And what are they going to do with all the others? They will kill them. And then you want to validate it in the opposite sex and will say, okay, I only want females. And what will the animal facility do with all the males? So potentially, this can lead not to using twice as many animals, but actually 4 times as many. And I will argue that killing healthy animals only due to their sex is ethically indefensible, and actually it is incompatible with a culture of care. So to wrap this up, there are both scientific and ethical costs of single-sex studies. There's missed data. We are missing the interaction between, say, drug and sex when one tests one factor at a time. There's bias. So only using females if results in males are promising, there's waste. So we might be using twice or even 4 times as many animals and sacrificing healthy animals needlessly. And this actually has an impact on the staff. So it contributes to compassion fatigue, and as I pointed out, it is incompatible with a culture of care. And we have an alternative, fractal designs using both sexes. It will prevent waste, therefore being more ethical. They will improve external validity, the generalizability of your research and its translational relevance, because we come in at least 2 varieties. There's no default sex. Why completely disregard half of the human population that we wish to model? It supports staff well-being and, of course, aligns with ethical requirements, scientific standards, and I would say public expectations as well. If you want to know more about how to do this, how to get more science without using more animals, please attend this session tomorrow, led by myself and Dr. Derek Fry. And I am open to your questions, either now or later. Thank you.
Thank you.